Well, here we have a given proportion. CB is to BA as DE is to EF. Well, to make this a little easier, I'm going to assign a variable here because I don't like having to say BA. A little bit easier there. So now I can write it like this. 6 is to S as 4 is to 7. This is certainly a case for cross multiply. And when I do that, I've got 4s equals 72 from my cross product, and now dividing by 4s, the missing side, also known as AB, must be 10.5. Let's use this given proportion to solve for the missing side. That would be XV, and I'm going to use that, I'm going to designate that with this letter X, so I can use a single variable. Now I'm also going to do a little addition. I'm going to take 12, add it to 5, and that gives me XV, 17. That's a necessary step. Now, those of you who are reading ahead in the book, you see what's coming. What we're really saying is this figure is similar to this figure. So again, the 12 and 24 of this triangle correspond to the 17 and the X of this triangle. But that's for a future section. Let's just stick with this. Now, we're going to directly substitute, and we could be done. At this point, what we could do, we could just cross multiply like this. But we want to learn more than one way to solve an exercise, so let's do this. Multiply both sides of the expression on the left by 2, and you see what's going to happen. I'm left with 24 over 34 equals 24 over x. Now to get down here, well, what we've done, I take the reciprocal of both expressions and I'm flipping them left to right. That would be symmetric property. And then you can see very plainly that x is 34. Multiply both sides by 24 and we're done. X, the unknown side, is 34. So let's follow this diagram and this given proportion. There you go. Let's bear in mind that CA is right here. Remember to add those two segments together. So CA is 21 is to 14 as 18 is to my unknown BD. And there it is. Now, you could just cross multiply and I could put in a single variable, but I like to do them all just a little bit differently, give you more ways to see it. And here, instead of cross multiply, I'm going to do this. I'm going to simplify the proportion, also known as a fraction on the left, to 3 halves. So I've got 3 is to 2 as 18 is to BD. Well, I could also do this. I could also say, well, let's multiply that fraction or ratio on the left by 6 over 6, just that one side. And you can see I'm going to 6 times 3 is 18, 2 times 6 is BD, which must be 12. And there you go, you're using similar fractions. Another proportion, another diagram. However, I'm going to have to add a few segments together, specifically right there, because I've got SQ is to SR as TV is to TU. So there's my substitution right there. Now, you could go directly, just go for the gusto and solve it. 3x plus 21 equals 70. That's okay, you can do that. But we're going to be more clever. We're trying to use these properties we just learned. So let's take an alternative approach. You know that thing about adding a denominator to each numerator? Well, I like the subtracting better. So, look at this. I'm going to take away 7 over 7 from the left. I'm going to take away 3 over 3 from the right. So x is to 7 as 3 is, or so x is to 7 as 7 is to 3. Again, Dizzy saying this. I cross multiply, this is what I get. And then I can solve it. X is 49 thirds. Finally, just simplifying it to mixed numbers, 16 and 1/3. But wait, let's go back to this. Check this out. This original proportion simplifies, ready, to X is to 7 as 7 is to 3. Blue is to orange as blue is to orange. Pretty slick, huh?